Hi everyone, this is Ayush Jaswal and I am making an explanation video of data science and semester paper of question 2a, where we have to demonstrate an algorithm that uses Bayes theorem to solve a small example where prior probabilities and livelihoods are given. Now, what is a Bayes theorem? A mathematical formula that describes how to update probabilities based on evidence. Inserting conditional probabilities, finding cause, given effect, medical diagnosis, spam detection, and priori PA. And livelihood we will take as P of B by A. And evidence is P of B, and posteriori is P of A by B, and Bayes theorem is probability of having A in B is equals to probability of B in A into P of A divided by P of B, where example we will take as disease diagnosis test, where a scenario is a medical test for a disease has 95% accuracy. The disease affects 1% of population. If a person tests positive, that is possibility they actually have the disease. And event A, uh, where event A is person actually have the disease, and event B is person test positive, and our goal is to find the probability of A in B, and where P of A is have disease and B is positive test. Now we will go for this. Now prior probability is 0.01 and test accuracy is 0.91, and false positive rate is 0.05. Now we are calculating P of B, probability of B. The total probability of positive test is P of B equal P of probability of B in A and to P of A, and P of probability of P not in A into P of probability of not A. Now we have calculated and got an answer as 0.059. It means 5.9% chances of testing positive, whether disease or not. Now applying Bayes theorem, we got P of probability of A in B is as 0.161, and in percentage it is 16.1%. Now the key insights from the result are where only 16.1% person actually have disease despite positive test, while disease is rare 1%, so false positive is 5% of 99% outnumbers true positive. Prior belief started at 1%, update to 16.1 based on positive test. And medical implications, positive test should promote future testing, not diagnosis. Bayes theorem algorithm steps: define hypothesis A and evidence B, identify priori, find livelihood. Where we have defined hypothesis, clear state what you are testing, and identify priori, initialize probability of hypothesis before evidence, and find livelihood, probability of B in A, probability of evidence if hypothesis is true, and calculating the probability of evidence using law of total probability and actual apply formula to compute probability of A and B, and where interpreted result to update belief about observation and evidence. Now Bayes theorem in data science is used for classification, that is naive Bayes classifier, for spam detection, test categorization, and in decision making like medical diagnosis, risk assessment, and fraud detection. Bayes theorem is a powerful tool for updating beliefs based on evidence. Starting with the prior probabilities, we incorporate observed evidence through livelihood to arrive to a posteriori probability, the revised understanding of reality, essentially for probabilistic reasoning in data science and machine learning. Thank you everyone. I hope you like this video. Please